Yesterday, we talked about how to deal with adding and subtracting monomials. And we said we really had learned that already because it's just like adding and subtracting like terms. And so today we're going to take it to the next level. Instead of adding and subtracting, our job here is we're going to multiply monomials. Now, in order to multiply monomials, there's a couple steps. We're just going to multiply the coefficients. That's that number in front of the variable. And then we've got to simplify the variable with something we call the product rule. So we really need to know what is the product rule and how does it work. So I've written down the notes that you should be writing down as well. And the first thing I'm going to look at then is how do I deal with the product rule? What is the product rule? So the product rule is pretty simple. And I kind of like it because it makes life pretty easy. Here's what the product rule says. If I'm multiplying two monomials, when I get to the variable portion, as long as the base is the same, in other words, as long as x is the base and I have some exponent, then I'll take those two exponents. In this case, I haven't told you what the number is. I've just said it's A and this one's B. I can add their exponents. Now, remember, don't confuse that with what we talked about yesterday. When we add and subtract, the terms have to be like, and those exponents have to be like, but it's okay to multiply variables with exponents. And when we do, we add those exponents. I'm going to show you why that actually works here in just a second. Okay, so we'll multiply the coefficients, and then we'll simplify the variables using the product rule by adding their exponents. Look at number one. Now, number one is 4x squared times 3x to the fifth. Now, I'm going to show you why this works. This works because remember that 4x squared is 4 times x, and x squared literally means x times itself twice. That's what it means. Likewise, 3x to the fifth means 3 times x, 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 okay? 5x's, x times itself 5 times. That's what it means. Now, the product rule says, you don't have to write all that out. 3 times 4 I know is 12. And then these both have a base of x, so I'm going to add their exponents. 5 plus 2 is 7. It works because there's 1, 2, 3, 4, 5, 6, 7 x's that I've multiplied by definition here. So it's kind of a shortcut way to handle multiplying monomials. Let's look at number 2. This one is 5 times 6, which I know is 30. And then it's going to be x to the 2 plus 4, x squared times x to the 4th, which will be x to the 6th power. That doesn't seem too bad. Let me give you another one to try. Let's make it a little more challenging. Write this one down, please. Negative 4 a cubed b times 3 a squared b to the fifth. All right, so I've got a negative 4 times a positive 3. That's a negative 12. Then a to the third times a squared. I just have to go 3 plus 2, which is 5. Okay, now I will tell you the first place that you're going to make a mistake, if you're not careful, is you'll want to actually say 3 times 2, a to the 6th. That's where you're going to want to make a mistake, but you don't want to do that. you want to add those exponents. Next variable is b, but I will remind you that b without an exponent is still b to the first power. So I have to say 5 plus 1 or 6. Second place folks will make mistakes is they'll forget to add that exponent of 1 because it wasn't written there. And they'll try to call this b to the 5th power. Write this one down, please. Negative 7 p to the 9th, q to the 3rd, r times negative 4 p squared times q to the 6th times r to the 4th. Let me let you try that one on your own for a second. Write that one down and tell me your answer. Anybody want to tell me what they got for that one? Yes, ma'am. Got two. Do what?
I got negative 11p.
Oh, hold on. Let's back up just for a second. Remember, we're multiplying. So you're on the right track, except it's not going to be a negative 11 because we're not adding. So negative 7 times a negative 4 would be what? Positive? Yeah, okay. So that's all right. Not a problem. Okay, now, p to the what?
I did 9 plus 2. And that got me 11.
9 plus 2, right? So that's p to the 11th.
And 3 plus 6 equals 9.
Yes, q to the 9th.
Since there's nothing besides the r, I did 1 plus 4, which is 5.
Yeah, r to the 5th. Very good. Perfect. 28 p to the 11th, q to the 9th, r to the 5th. All right, try number 5. I have an answer for number 5. Luke, do you have an answer, sir? All right. One thing before he gets started, I'm going to point out to you, we've got x to the first, y the first, x to the first, y the first. I'm going to put those little ones there. So what do you get for this one?
So the correct answer would be negative 6
Yes, sir.
on the x raised to the power and y raised. No, wait, x would be raised to the 4th power and y would be raised to the 5th.
Yes, sir. Negative 6, x to the 4th, y to the 5th. Perfect. You had to add up 1 and 1 and 2. So that was 4. 1 and 1 and 3. You got 5. Write number 6 down, please. go ahead and raise r to the first power, s to the first power, just so that I've got that in there. -4 times -5, positive 20. R to the first times r to the fourth is r to the fifth. S squared times x to the first, s to the third. That brings us to number 7. Number 7 is pretty straightforward, but up until this point, I haven't thrown in subtraction. Now remember, we have rules for adding and subtracting monomials. They have to be like terms, so we understand that. Here's a subtraction sign. And then I've got the first part that I can multiply together. I can do that. And I can also multiply the second part together. So I'm going to kind of take it one step at a time. Remember, I can't subtract them unless they're like terms. Went ahead and added in to the first power. So this is -5 times -3, which is a positive 15 c to the fifth power, and then it'll be d squared, or d to the second power. On the other side of the subtraction sign, 7 times 2, 14. C to the fifth power, here's the 2 and the 3. I add those two to get the 5. And then d squared. That's true. You go that clever. Yeah. Well, then you got to go down, clever down to in case. From there. Yeah. You're welcome. No problem. See. So at this point now, got a subtraction problem because I multiplied each side or each part, each term, and I get to the subtraction portion of it, and I notice I have c to the fifth d squared because the exponents are exactly the same and the variables. I have like terms. So 15 minus 14 is 1 c to the fifth d squared, and don't actually have to have that 1 up there. I could say, well, it's just c to the fifth d squared. So the key, what we picked up today in trying to get ready to work in this problem,